Alright, number 15. So we got A, B, C, and D are points on a circle at center O. AOC is a diameter circle, which means this straight line across with two radiuses and a perfect diameter. Angle AOD is 98 and it's labeled here. Work out the size of angle DBC. So D going to B going to C. In other words, the angle between it. We can call it X. Okay. So give a reason for each stage of your working. Alright, so they want us to be descriptive as well. Now, when you look at this one, we need to observe two things, yeah? First thing is this kind of spacecraft shape, which is a very common shape, which looks like that. This means here that whatever angle you get here, the angle in the center is always 2 times the value of the angle at circumference, yeah? So for instance, since this is 98, this needs to be half its value. So this would be half of 98, meaning 49 degrees. So that's easy, yeah? Now, another shape you need to realize is the fact that we have a diameter. And this is kind of the shape of a semicircle now. If you think about it, this is just a semicircle. And one property that's important to know, that any triangle inside the semicircle is always right angled. So this means this is always a right angle. In other words, 49 plus x must equal 90 degrees. And if you subtract these two, well, you get your answer. So 90 take away 49 should give us 41 degrees. And that's it. And just to be clear, the properties I was talking about earlier are these. And they are these two. Well, the first one being the angle at the center of a circle is twice angle to circumference. This means, like we had earlier, this was 98 degrees, so therefore this must be 49. And the second type was the fact that the angle in the semicircle is 90 degrees. So you got a diameter cutting across, meaning any single triangle you form, could be there or downwards, like here for instance, will always be 90 degrees. So anywhere you do, like from one point to the other point, yeah, like this, and so on, yeah. And that's it. That's literally it. All right, number 16. So the following table gives values of x and y where y is inversely proportional to the square of x. All right, before we carry on to the rest, inversely proportional means something like this, that y is proportional to the inverse of the square x. So a square of x is x squared. The inverse of it means it's reciprocal, so 1 over symbol over here that we got, this kind of little fish thing which looks like an alpha. This is some proportionality symbol, but it can be converted to an equal sign, which is the same as equals some scale factor. So what they really want us is to make an equation that looks like this: y equals some scale factor k over x squared, where k is something we have to solve. That's literally what we need to always find, the value of k, the scale factor. Now let's look at the question. A, find the formula for y in terms of x. So in other words, we need to figure out what k is, and then we have an equation for y in terms of x. Now with this table over here, we just plug in, I don't know, 2 different values, or one of them, find the value k, and you're done. So I'm just going to use these two, because it looks quite simple to use. So this means when x is 3, y is 4. So this equation means 4 equals k over 3 squared. 3 squared is 9. So solving for k, but multiplying 9 across, 4 times 9 is 36. So 36 equals k. So therefore, our formula for y in terms of k is y equals 36 over x squared. And that's it, guys. That's this one done. Now for the next bit, it says that given that x is positive, i.e. x is greater than 0, find the value of x when y is 144. Alright, so using the formula above we just got, let's go ahead and plug in, replace y 144, yeah? That's going to equal 36 over x squared. Now, let's go make x squared a subject, so timesing x squared across and dividing 144, we're going to have x squared equals 36 over 144. Now, all you want to do is find x, so square root in this. You're going to have x equals the square of these numbers, which is square root of 36 is 6 over 12. And because it says x is, what's it called? X is greater than 0, we don't need to write plus minus. Only because they want a positive result, so they only want the plus answer. And then, yeah, 6 over 12 is just half. I mean, you could just put this in your calculator and square root, and you should get half as well. But either way, guys, this is the end of the question. Okay, guys, I'm not gonna lie. This question was a bit challenging, and it's quite different to what you've seen before. But anyways, let's try and break it down to make it as simple as possible, yeah? So, question 17. The table gives information about the first 6 terms of a sequence of numbers, alright? So here are our first 6 terms from 1 to 6. Now for the term sequence, we got 1 times 2 over 2, 2 times 3 over 2, 3 times 4 over 2, and so on. So what's actually happening is that they're borrowing the term number here and substituting here, and then increasing the next value by 1 to make it 2. Same here, they got number 2 to correspond here, and they increase by 1 to get 3. They put 3 here, increase by 1, and so on. And it's always dividing by 2. So dividing by 2 is fixed. Alright. Now it tells us that we need to prove algebraically that the sum of any 2 consecutive numbers, so consecutive terms, so basically one after the other, of the sequence is always a square number. Alright. So we're going to get to that square number in a second. We just need to pick 2 consecutive terms and kind of write it algebraically. So let's find the m term, yeah? Suppose the m term at this stage, if the term number was n, we would copy it here, so it would be n. So let's make a little table. We've got n and n plus 1. These are 2 consecutive terms, yeah? So I'm going to use a table. So this means we're going to have n times increased by 1, n plus 1 over 2. So the next term would be n plus 1, increase it by 1, times it by n plus 2 over 2. Now it's telling us the sum of these 2 consecutive terms. So this means n over n plus 1 over 2 plus n plus 1 n plus 2 over 2 must equal a square number. So this is what we have to prove here. So let's go ahead and try and simplify this this fraction. So summing this up, because they have common denominators, we can add the top directly. So let's expand this then, make it all over 2. So you got n times n, so you got n squared plus n times 1 is n, plus now expanding the double bracket, you got n times n is n squared, n times 2 is 2n, and 1 times n is 1n, 2n plus 1n is 3n, and 1 times 2 is 2. And we know it all has a common denominator of 2. Now tidying up the top half here, so let's just go ahead and tidy up top half, guys. Collect like terms, so you got n squared plus n squared is 2n squared, plus n plus 3n is 4n's, plus, and you just got a constant 2, and all of that over 2. Now looks like we're getting somewhere, yeah? Now let's go ahead and see if we can simplify this. Yep, they're all in 2 times table. Divided by 2, you get n squared plus 2n plus 1. Alright, so we're not done yet, yeah? Because the thing is, it tells us that this sequence is always a square number. A square number means we need something squared. In other words, they want us to try and factorize this last step. Now this can really catch you out, yeah? So to factorize this quadratic, we can just put in a double bracket like that, yeah? Just start something simple. We know that the first terms on both sides is n, because n times n is n squared. And we need 2 numbers that multiply to make 1. Well, the only possibilities is 1 times 1. And the same 2 numbers that sum to make 2. Well, 1 plus 1 is 2. So that means they both must be 1 here. Plus 1 and plus 1. And guess what, guys? And then you combine together, this is literally n plus 1 squared. And that's it, guys. We're all done. Alright, number 18. So the functions f and g are defined as follows, yeah? So the first function fx is kind of like a fraction, and gx is just some sort of linear term. Now, part A. State which values of x must be excluded from any domain of the function f. Okay, so we're talking about the first function fx, yeah? Now, when it says state the domain that must be, like state the value x that must be excluded from a domain, all it's asking here is that we want to check which values of x is not allowed. So when we got fractions involved, we need to ask ourselves, okay, what doesn't work? So one important thing about fractions we need to know is that we can never divide by 0. Okay, in other words, the denominator cannot equal 0. So the first thing we want to is try and figure out what values of x will make it 0. That's what we need to exclude. So then we can say, all right, let 4x minus 3 equal 0, because we can't have that. Solving for x, you're going to have, therefore, plus and 3, so 4x equals 3. And dividing by 4 across, x equals 3/4. So this is the value of x that we must exclude from our domain. Otherwise, you're going to get something over 0 and then it's undefined. Okay. Now, part B. Find f(g(x). Simplify answer. All right, this is just a standard one, yeah? This means you're going to have to put g, the function of g, inside f, yeah? In other words, you're going to put this into here. You're going to replace x, the x is here, with x minus 5. So let's do it, yeah? So if we've got f(g(x), I'm going to use different colored pens, yeah? I'm going to replace this x and this x with x minus 5. So now we've got x minus 5 over 4 times, and then replace that with blue, x minus 5, and then the original minus 3. Now we just simplify that. So x minus 5 just stays at the top. The bottom you could just expand the bracket. So 4 times x is 4x. 4 times 5 is minus 20, and then minus 3. And then just tidy this up a bit. You're going to have x minus 5 over, and then the bottom would just be minus 20 take away 3, which is 4x minus 23. That's it, guys. Like, nothing more to it. Now finally, the last part, C. Express the inverse function, this thing, so f minus 1, in the form of, well, the same. I can never really read this, man. It's always kind of weird to read. Now, to find the inverse function of f, so let me just clean this up a bit. All you got to do is just do the same steps as always, yeah? So just say, all right, so basically replace all your x's with y. So let fy equal y over 4y minus 3. And this time, we just equal it to x. It's always like that, yeah? Replace all letters of y, make it equal to x, and then just rearrange it to make y the subject. And you're done. That's always the same thing, yeah? So we're basically trying to find all of these lot, yeah? And make y the subject. Now, to do that, to make y the subject easily, you always want to clear the fraction, yeah? So let's times 4y minus 3 across. So we're going to have y equals x times 4y minus 3, which is 4xy minus 3x. Remember, we just times this across here. Now, all you want to do is isolate the y. So basically, move all the y's to the same side, yeah? So I'm going to move 4xy to the left side. So we've got y and 4xy. To do it, we subtract it. So we've got y minus 4xy equals, and you're left with minus 3x on the right. Now, next step you want to do is factorize the y out. So we're going to have y bracket 1 minus 4x equals minus 3x. And lastly, guys, all you got to do now is simply divide this bracket to the other side to make y the subject. So you can get y equals minus 3x all over 1 minus 4x. And you're done. And then you just change the y into to that symbol they want. F to the power of minus 1x. So this is the inverse symbol, equals minus 3x over 1 minus 4x. You might have an alternative answer, by the way, yeah? Other alternative answers, which is fine, would be 3x over 4x minus 1. Because if you just flip both of these, it's the same result. So you can have this result or this result. Either one is fine, guys, yeah? Okay, and the last bit. So part of the curve of equation y equals hx is shown on the grid. Okay, so you got this hx curve. Find an estimate for the gradient of the curve at the point where x equals minus 0.5. So minus 0.5 is here, yeah? So it's talking about finding a gradient at that point. In other words, you just got to draw some sort of tangent line, like this, yeah? Show you're working clearly. All right, so you kind of just need a ruler. So all you need to draw is maybe, I don't know, something like that, yeah? Some sort of straight line. Probably better, I should have used like a ruler or something. And all you want to do is just pick 2 random coordinates. I don't know, maybe, ooh, this is kind of hard. So probably something like here and something like here or something, yeah? So this point here and this point here, let's have a look. This is just 0, 18 maybe. And this point here is just, what is it? So it's minus 1, 11, yeah? And now all you want to do is just kind of find a gradient of this line. So the gradient formula is always the change in y over the change in x coordinates, yeah? So, well, the change in y is just the difference between the y, so 18 take away 11. And the same thing, change in x would be 0 take away minus 1, so 0 take away minus 1. And when you put this in the calculator, well, you should get a gradient of 7, or around 7. Because I'm not using a ruler, I might be a bit off, guys, yeah, so double check. But I think I've checked the math scheme and the answer should be kind of, yeah, the answer is actually 7. It's all good. Anyway, guys, see you in the next one. Alright, number 19. So the diagram shows a sector OAPB of a circle center O. Alright, so this is just a nice simple sector, yeah? Part of a circle. Now, AB is a chord of the circle. AB, so AB, yep, it's just a chord. Angle AOB is 80 degrees. The area of the sector of the whole thing is 25 over 2 pi. So this is actually very important, yeah? And just quick note, yeah? This little area here is called a segment. This area here is called, well, it's a triangle. I think we know that one, yeah? Now, Work out the perimeter of the shaded segment. Give your answer correct to 3 similar figures. Okay, so it looks to me that all you really need to work out is this arc length here, as well as and since it's part of a circle, these two will be the radius r, yeah? Okay, not too bad. So let's just recall some formulas, yeah? We need to know firstly that the circumference of a circle is 2 pi r, yeah? This is a fraction of a circumference of a circle, yeah? So let's say this is 80 out of 360 degrees. So the length arc, which is what we need, is a fraction. So 80 over 360 of your circumference of a circle, 2 pi r. That's really how you calculate, yeah? We also know that the area of a circle, there's a bunch of formulas, guys, yeah, is pi r squared. And the area of a sector, so this is area of a circle, the area of a sector is a fraction of the area of a circle. Again, it's like 80 out of 360 degrees. So 80 over 360 times your area of a circle. Okay. Now, what do we need to calculate, yeah? So we have to always think about the objective, yeah? So since we want the perimeter, we can only work out the perimeter if we know what the radius is, yeah? So we can actually answer this question if we can work out the radius. Since they gave us the area of a sector, we already know this value here. It's actually 25 over 2 pi. So updating that, put in 25 over 2 pi, we can just solve it. So to find r, all you do is literally just smash everything to one side, yeah? And before doing that, looking on both sides, we can cancel pi because they both have pi. So dividing pi on both sides, left of that. And now we can divide 80 over 360 across and then square root to find r. So you're going to have 25 divided by 2 all over 80 divided by 360 equals r squared. So putting all of this in the calculator and then square rooting your answer, you should get a radius of 7.5. That's what you should have, yeah? Now, because you got the radius here, we can update these values right here. So again, we're trying to find the perimeter, yeah? So just let me see, what we're trying to find, what perimeter exactly? Work out the perimeter of the shaded segment. Okay, so they're talking about this arc plus this bit here. Okay, so you want to work out this length too. Man, that's a lot of steps. Okay, cool. So let's have a look. What should we work out? Let's work out the length of this arc, yeah? This arc is L. That's what we called over here. Since we know what the radius is, we could just plug it back in and we got it. So the length of the arc L. Okay, so we should get roughly 10.47 ... Okay, so that's done. So we found this bit. Arc is covered. Alright, now we just want to work out this triangle, the length of this opposite length from 80 degrees, yeah? Let's just call it X. Now, looking at this carefully, this triangle, the only way we can solve it is using either the sine or cosine rule, right? But because we've got 3 lengths, X, 7.5, 7.5, and an angle, we can only use the cosine rule. So let's just recall the cosine rule, yeah? The cosine rule formula said that we have a squared, which is equal to b squared plus c squared, and we must minus 2bc cos a. And by the way, this is given in the front of the booklet, yeah? So replacing all the known values, because we've got one angle, this is ultimately an a, yeah? That means that the length opposite the angle must be little a. And that means these two values are b and c. So updating everything, we got x squared equals 7.5 squared plus 7.5 squared again minus 2 lots of 7.5 times 7.5 cos 80 degrees. Okay, perfect. So putting that all in, so putting all of this in your calculator and then once again square rooting your answer, so square root whatever your answer says, you should get a value of, I think, 9.64 ... And yeah guys, we're pretty much done. Because we got the length of the arc and we got our x value, which is here, so we basically got everything. We got the arc plus this value, so that's just 2 lengths. We just add them up to get the perimeter. So the final answer would be 10.47 plus 9.64, and doing so you should get an actual perimeter length of 20.1 centimeters. Yeah, and that's it guys, that's it, we're done. At least we're done for now. So if this video helped, let me know what you guys think. Leave me a comment or give me some suggestions or anything else. But other than that guys, you know, good luck with your revision and everything, and I'll see you guys in the next video. Ciao.